How do particles choose their paths through a field? Are they just being pulled by some invisible force? Or are they actually finding their way? In the energy filament theory, the answer is particles aren't being dragged. They're actively finding their path. Imagine the entire universe as an energy sea, with a slope plus texture map laid out. The tension field shows you where the sea is tight or loose, and the texture field tells you which paths are smoother and less likely to cause friction. The interaction between the two maps creates a landscape that guides the particles in the most efficient way. We've already discussed in Season 2 that each particle has its own near-field texture. Think of it like the tread on a car tire. Some tires are built for mud, others for highways. In this view, the particle's movement through the field is the result of a combination of three things: the slope of the energy sea beneath it, the direction of the surrounding textures, and the texture of the particle's own tread. These three elements combine to automatically choose the most stable, energy-efficient route. What you see as the particle's path is actually the result of trial and error, where the field filters the path routes that are too difficult quickly break down, while the ones that are easiest continue to guide the particle. Different particles, due to their distinct near-field textures, prefer different routes. Electrons love the paths formed by electric and magnetic textures, making them extremely responsive to these fields. Neutrinos, on the other hand, are almost indifferent to electric and magnetic textures, only responding to the large-scale tension terrain. Protons have to navigate both the internal nuclear forces and the external slope of the energy field, instead of being pulled by some mysterious hand. You can think of the field as providing all possible routes, and the particle simply picks the one that is the least strenuous for it. This view flips the traditional idea of forces and fields. Rather than thinking of a force as something that acts directly on a particle from the outside, in this picture, the field offers a variety of routes, and the particle picks the one that's easiest and most energy efficient for it. Next season, we'll translate force into the visual effects left by the paths particles choose. But for now, remember this: particles aren't being dragged along in the field. They're continuously selecting the easiest path on an invisible map. Tap follow, share it on New Physics, Clear Universe.